Now let's look at the rho gy terms. So if we want to take the potential energy, we assign here a 0 value for y1, and above it we have the value of h. So at the potential energy at y2, this value y2 becomes 0 because we set this to be 0. So this is just an arbitrary assignment for ground. So now we are left with rho gy1 plus 1/2 rho v1 squared equals 1/2 rho v2 squared. Now I will also replace y1 to be h, since that is the height at which this fluid is rested. H. So now let's look at the 1/2 rho v terms. So here we have v1, the velocity of the fluid in this region, and here we have v2, the velocity outside the hole. So if the hole is very little in area, we know from continuity equation that v2 will be very large. So we can make an assumption that v2 is very large compared to v1, such that v2 minus v1 is almost equal to only v2. So we can treat v1 to be 0. So I hope that makes a bit of a sense. So v1, we can treat this to be near 0. So rho gh will only be equal to 1/2 rho v2 square. We can solve for the exiting velocity v2, which is equal to rho cancels out, and if we take the square root, it will be square root of 2gh. So this is a special formula. This is called Torricelli's law. So Torricelli's law explains the velocity, exiting velocity, that is dependent on the height at which the fluid is filled. So if we have a hole here and the fluid, you have a height of a fluid filled, the exit velocity of the fluid will be defined by h. So in this problem, I leave that to you to solve for v2, and using kinematics, you can actually solve for distance x.